Welcome back. Here we go. Chapter 2. All right, so chapter 2, we are going to take this section by section so it's not being crammed at you all at once like chapter 1. So section 2.1 is all about visualizing numerical data. So here we're going to talk about nothing but numerical data, okay? So throughout chapter 2, we're going to be talking about all sorts of visualizations of data. So please know that you do not have to create any of these by hand. Near the end of this, I'm going to show you how our lovely StatCrunch is going to help us kick some major booty in doing a lot of these plots. StatCrunch is amazing. Throughout this entire year, I'm going to show you StatCrunch. It's awesome. And I'm also going to show you how you can do stuff on your calculator. Our calculator can do a lot of these visuals, but I'd rather use StatCrunch for it. So I'm not going to show you the calculator portion for this part. But I will definitely show you some calculator tricks with the TI-84 and StatCrunch. You can always use it on homework, quizzes, and tests. So you will never be without StatCrunch. Promise you on that. Okay. So let's go ahead and get started with visualizing numerical data. In here, we're going to talk about 4 different displays. Okay. So our first one, we've got some data collected here. Again, I use a lot of the book information, so a lot of this I just took from the book and put it out here for us. So this says the number of goals scored by NCAA female soccer players in Division III in the 2012 season. And that's a very descriptive title. Titles are very important whenever you do any visualization of data, as you found out in my last video when we did the stacked and unstacked example. I didn't have a title for the 5 p.m. and noon data, and that threw us off because we couldn't tell if it was stacked or unstacked based off of that information. So, or let alone know what you were looking at. So titles are very, very important. Please keep titles going throughout your data. Especially when you're making visual diagrams, so we know exactly what we're looking at. So these next couple examples are going to be all about this data that's right here. Okay. So female soccer players in Division III in the 2012 season, goals being scored NCAA. All right. So the first one is we can talk about a frequency table. So a frequency table, all you do is you list the data values that you have. So notice that they are in order and they are just the data values like 9, 11, 12, 13. And then over here is the frequency. 9 only happened once. 4 happened 4 times. So let me do this. Let's pin this in place. So you can see what I was talking about there. You can see that over here, that 9 value only happened once. So it had a frequency of 1. The 11 value happened 1, 2, 3, 4 times. So it had a frequency of 4. And then so on and so forth. So you can see, and down here, there's that, kind of title that I was talking about. Very, very important. So even better, it said by first year women soccer players. I probably should have that over here somewhere, but so even more important, these are all first year women soccer players in the Division III. So a frequency table, all you do is you just list your values and then you tack out how many happened for each value. Okay, so you can see there's only one 12 value that happened. It's right over there. So that's how we make a frequency table. List out your values, and that's a horrible circle. And then tell me how many times it happened. Okay? So frequency table is a way that we can display our data. Frequency tables, when we start talking about like mean, median, and mode, frequency tables are a good way to help us find those measures of central tendency, especially when it comes to the mode. Okay? So look at another one. Oops. There we go. We have what is called the dot plot. Okay, a dot plot is kind of like a frequency table again. So again, over here, we've got that title in there. So we know what we're looking at here. And each dot represents a data value. Each dot represents one of the first year women soccer player. Okay, And so all we did was take these pieces and we put like a number line below it, okay? And we put a dot above when each value for the number of times it happened. So you can see right here, this is where the 11 is at. And there are 4 dots above it. And then we got the 12. Okay, we got 1 dot above it. Over here, this is the 9. So you can see that our little number line right here, it definitely skips over. It doesn't start at 0. Okay, there's no y-axis here, even though we draw on that line. You don't have to have the y-axis there. Okay, there's nothing on it, but each dot, notice the dots are all level. So when we place that first dot, every first dot that follows is on that same level, and they're all spaced apart accordingly so that the second dots are all lined up row by row, the third. Okay, so dot plots is very organized, and everything is in nice, neat rows across and columns. So again, this one is where we can start to look at a little bit of, the shape and how dispersed the data is, where when we are looking at the frequency table, it's not as obvious. But here you can see that there's some nice spread to our data, which we'll talk about the shape and spread in 2.2. Okay, but right now we're just in 2.1, so we're talking about these different displays. Okay, so you got a dot display right here, dot plot. That's what it looks like, and it's just dots of each data that we had over here. So you can see those dots. You can see that we've got that 1 black dot here, and then we've got the 4 red dots for 11. And then we've got the 112 dot, okay? So all those dots represent each one of those data pieces. All right, there's dot plot. Then we have what is called a histogram, okay? So a histogram looks like a bar graph, but what's important about the histogram is that the bars have to touch each other, because this is like a running number line down here, okay? And each bar is what we call a bin, B-I-N. Each bar is a bin. Okay, and over here represents the frequencies. So generally when you have your frequency table, we usually take that frequency table and we turn it into a histogram. So what I want you to understand about these bins is that this bin that's right here, this 9 to 12, that really represents 9 to 11. So any values that were in 9 through, any soccer player that scored 9 to 11 points are in this bin right there. This bin right here is 12 to 14. Okay? So the number that you see right here, the right part of each bar is the beginning of the bin. Okay? And it spans 3 numbers. So a couple of things that I have down here. Data values that are on the boundary. So like any value that is like 9, as a common rule, they are put into the right bin. So anybody that's 9 is inside here. Anybody that's 12 is inside this bar right there. Anybody that's 15 is inside this bar. And notice these bins all have the same width. That's important things to note. So when it comes to histograms, just some things that I want you to know is that you have what are called bins, okay, which are the bars. And the bars are all the same width. So all of our bars up here are a distance of 3, 9, 10, and 11. That's 3 numbers. 12, 13, and 14. That's 3 numbers. 15, 16, and 17 is what occur in here. That's 3 numbers. So they all have the same width. And all the bars are the same thickness. And touch. So histograms are very important like that. The bars should all touch. Even though you don't see bars here, there are bars. They're actually on the x-axis right here, blending in with the x-axis. So there are bars here because they represent 0, Okay, so there are bars that are making these all touch across there, and they're also the same thickness. So we won't have a histogram where we have a skinny bar, then all of a sudden, because there's more in the second one, we make it thicker. Histograms don't do that. Okay, all the bars are the same width and thickness. All right, so that's important for you guys to know. Okay, so that's what a histogram looks like. And again, we're going to have our StatCrunch deal with that for us. Okay, so a couple of things. I've got some faux pas about. Oh, nope, before I get to the faux pas, we'll talk about this real quick. So relative frequency histogram. So a relative frequency histogram, all this is these are the percentages. Okay. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. We had 28 entries. So over here, inside the 9 to 11, there were 5 data points. Okay. You had the 9. And then the 4 11s. See, that's 5. 1, 2, 3, 4, 5. What a relative frequency histogram does is it takes that 5 divided by, I said 28, right? Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Yes. So they take that 5. Let's get this to right. 5 and divide it by 28. And when you take 5 divided by 28, so this is talking about those proportions that we talked about in chapter 1, and you do your rounding, you get about 18%. So you can see that this bar is right up there, about 18%. So that's all a relative frequency histogram is it's the proportions of each bar. Or in other words, what's the percentage of your data that falls in this bar. So 18% of my data is here. Up here, it looks like, I don't know, we're probably about 32, 33% of our data in there. So relative frequency histogram is the percentages of your data. So if you go back and look at this, so the 12 to 14 bar was up at 9. So you would take 9 divided by 28. And when you go to your calculator, 9 divided by 28, yeah, it was about 32%. I was right there. 32%. And you can see that this bar is up at the 32% mark. Okay. This bar just seems thick like that. There's no reason for that. It's nothing special. It's just the way it was printed. So this is not a thick bar that's right there. That's not, it doesn't happen like that. They're supposed to be, not as, the thin bar as everybody else. Okay. So this is just a printing error. So ignore that kind of thickness that you see right there. So that's all a relative frequency is. So, you just take the normal frequency or histogram and you turn these into percentages and you make a new one. That's all it is. So a couple faux pas and things like that to beware. Histograms. I'm showing you 2 histograms to be aware of. If you make your bends too small, okay, because you can control the width of the bends. You can control the width of your, how you want to do things. You just have to make sure that all the bends are the same length. So what you can see in this one, they made all the bend width 1. And so, while this isn't too bad, it does make it a little bit spiky for us versus what we had like right here. This is a little bit better to look at. Okay. So if you make your bins too small, there's too much data to look at. Versus over here, they made the bin width too wide. Okay. These bin widths are 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 23, 24, 25, 26, 27, 28, 20 wide. And you can see that's too thick. It distorts the data. So sometimes being too narrow, sometimes being too thick is going to distort your data. You're not going to be able to see. Like too narrow, it's just too much data to look at. And then right here, this is just funky, okay? Because there's a lot of information between 9 and 29. So you know, when we do StatCrunch, the default piece in StatCrunch. Why do I feel like I spelled crunch wrong? I'll figure it out later. So the default in StatCrunch, I think I have an extra H here. My bad. Is that the bin widths are 3. So it'll make your bin widths look like this. These are bin widths of 3. Okay. So StatCrunch, the default is 3, which is pretty good. Okay. So that's a histogram. And then the last one that you're going to look at in here is a stem and leaf plot. So here I have new data. I don't know why they didn't stick with the other data. I guess because there's not a lot of difference here. There'll be a lot of stuff under the ones and things like that. But here, what I have given you is a stem and leaf plot of alcoholic drinks consumed by college students. Each digit on the right, the leaves, represent a student. Okay? Together, the stem and the leaf indicate the number of drinks of an individual student. Okay? So if I have something that looks like this, where the stem is 0, the leaf is 1, that means that the college student had 1 drink. If I had a 1/5, that means the college student had 15 drinks. Okay? So up here you can see all the information, and then they just took this information and they made them into a stem and leaf plot. Okay? Generally, when you're making stem and leaf plots, if you ever have to make one by hand, know that whenever you're dealing with your number, so like say we have the number 7, okay? If it's just a single number, there really is a number that's right over here. It is 0. And when you make a stem and leaf plot, basically what you do is like you draw a line and hack off the rightmost number. Everybody before this line is a stem. Everybody after the line is a leaf. Okay? And with stem and leaf plots, we always keep our stems in order. So if, say, some college student miraculously had 60 drinks in one night and didn't kill himself, you would see a 5 and a 6 up here. Okay? Even though there were no 50s, we would still have a 5 because it's like a placeholder for us. We just wouldn't have any leaves on the 5. But the 6 would then have a 0 by it because there would be some student who miraculously had 60 drinks. Okay? So with the stems, you keep counting on down, even if you don't have any leaves to put there. Okay? So again, as I said, if I had that 61, I would chop off the rightmost digit. This is a leaf. And then over here is the stem, the 6. Okay? So I can take it out of dual screen page now. Let's go back into single page. There we go. So you can see this a little bit more up close and personal about what I was talking about. Okay? All right. Moving on. All right, so stat crunch time. Oh, before I can do that, I almost forgot. A couple things. Usually stem and leaf plots, we don't do much of them. Usually stem and leaf plots, we do when there is no technology available and you have small sets of data. Like this is a small set of data. A stem and leaf plot is not bad for that. But if I have like 100 pieces of data, or if I have 1,000 pieces of data, you're not going to want to do a stem and leaf plot for that. That's just ridiculous. And plus, you're going to have technology available for you. Stem and leaf plots, generally, again, we only use those if there's a small amount of data or there's no tech available. Okay? Other cool thing I want to show you about a stem and leaf plot is that if you turn the stem 90 degrees counterclockwise, Right here, what you have created is a histogram, where this is the bar for each histogram. And down here, these represent the bends, where each one of these bends is a bend width of 10. Because you got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is your 0 to 9. This is 10 to 19. This represents 20 to 29. And up here, because these things are nice and spaced, no commas in a stem and leaf plot, even though in college mathematics they made you put commas in. That's so incorrect. Because everything is spaced out accordingly. Everybody's in rows and columns right here. These represent your bars for your histogram. And they're all connected just like that. And the number of entries in here represent the frequency. So this is a frequency of 4, frequency of 2, 2, 1, and however many you got right there. Okay. So that's kind of a neat little feature of stem and leaf plots, that if you turn the stem and leaf plot 90 degrees counterclockwise, you have just made yourself the histogram. Okay. Kind of cool. All right, stat crunch time. I knew I spelled it wrong. I had an extra H. Silly me. Okay. Where was that thing at? There it is. I knew it. Okay. Stat crunch time. Let me show you some cool things on stat crunch. All right, so we're going to take this information right here and I'm going to show you what stat crunch can do for you. Okay. So let's talk about how to get into stat crunch. So we're going to come out here. You're going to want to go into your My Lab and Mastering. Okay. Click on My Lab and Mastering. You know, one day I'll probably make a link in the course directly to this, but for right now, let me show you how to get there. Okay. And right over here, you're going to see Stat Crunch. So click on Stat Crunch. And you're going to open in a new tab. And again, here it is. And you'll want to go to Stat Crunch website. Okay. And you'll want to open Stat Crunch. I know, a lot of steps. And then what I would do right here, I would take this and I would bookmark this page. You can see that I already have it bookmarked. Okay, I would bookmark this page because this is StatCrunch. Yay! So now that we're in StatCrunch, you can go ahead and close all that other stuff. Some things that you can do. So we have this data right here of full-time and part-time jobs and the number of times those students eat out in the last month. Okay, so this is probably close, if not maybe, to what we have been experiencing. So there's not a lot of eating out going on. Okay, so we have two categories, full-time and part-time. So these are our variables that we talked about in chapter 1. In StatCrunch, you can actually come in here and change that name to full-time. And all I'm doing is clicking on the variable and then changing it. Part-time. You don't have to if you don't want to, but it does help when you're kind of looking at some of this next information that we're going to be looking at. And then all you're going to do is come in here and put the numbers. You're going to put the number and then hit equals or enter. Okay. And I have the list out to the side. So hopefully you come back here, take a quick picture, and then you can go out to your StatCrunch and put all this information in. So take a picture. Okay, let's go to StatCrunch and let's put this information in. So full-time was 5, 3. I'm just hitting my numbers and then hit enter. 4, 4, 4. You're going to end up with 25 of these, just so you know. 2, 1, 5, 6, 5, 6, 3, 3, 2, 4, 5, 2, 3, 7, 5, 5, 1, 4, 6, 7. So Definitely got 25 answers. Good. All right. So over here in the part-time, it's, see if I can hide that for a second. Actually, we'll get rid of that for a second. There we go. Even better. Now that you can see everything. Over here in part-time, we have 1, 1, 5, 1, 4, 2, 2, 3, 3, 2, 3, 2, 4, 2, 1, 2, 3, 2, 1, 3, 3. Oops. 3, 3, 2, 4, 2, 1. All right, so there's our data. Big things when you're doing this, make sure that you always double check your data when you're putting in. Make sure that you have everybody accounted for. That's the biggest thing in statistics is generally when we start doing some analysis and making visuals and things like that, you got to make sure that you have all of your data accounted for. So always double check your data when you put it in. And then right here, now we can start doing some cool things. So we can come up to graph, and then right here is all that stuff I talked about. Histogram, stem and leaf plot, dot plot. Okay. We also talked about, well, frequency table. It doesn't really do the frequency table, I don't think, off the top of my head, but you could easily do a frequency table for this if you wanted to. Let me look here. Oh, chart. Let's look at chart. I don't know if chart will do it. So, all right. So when you want to do something, so you come down here and you grab whatever you want to do. So let's take columns. Let's see what columns does. I can't remember. I think that's our frequency table. And then you're going to pick what you want to work with. So we just want to do one of these. Let's say full time. And then don't change anything else. Just leave it the way it is. And come down and compute. Because pretty much we like all the defaults in StatCrunch. So we hit compute. There we go. So, I see what's going on. So this is person 1, and right here is their frequency. So it's charted our data according to their frequency. So down here is like the frequency, and over here is each data entry. Cool. If you want to adjust this, so you can come in and go into edit, and that brings you back up here to your information. Okay. So kind of some cool things. So let's go ahead and exit out of that. Let's see what the other chart and group stats. Let's see what that means. Just looking real quick. Yeah, I don't see frequency table on here, so don't worry about that. But if you needed to make a frequency table, you could. Really easy. But let's take a look at some of the other things that it does. So let's talk about histogram. Let's do part-time this time. So again, don't change anything in here. But you just select the part-time and say compute. Because again, in the histogram, it's going to keep all of these in bins of 3 if necessary. But since there wasn't a lot of information in here, they did bins of 1. But if there was lots of information, they would put them into bins of 3 if there was a lot of variability. So these should be connected. It's kind of treating it like a bar graph a little bit, but these should be connected. But there's what the histogram looks like. And again, you can see the frequency. So actually, you could take the histogram and make a quick frequency table from this, because you'd put 1 with a frequency of 6, 2 with a frequency of, looks like 9. And look at that. If you hold right over it, okay, it says frequency 9. And there you go. So 3 with a frequency of 6 and 4 with a frequency of 3. Okay. It's kind of some cool things. Oh, I see what it did. If you look at this, right below that, it says frequency 6, part-time, and it's giving you the width of the bin. So each bin is 0.5 long. Okay. So 1 to 1.5. And then in the next bin over here, this will be the bin that is 1.5 to 2. I see what it did. So if you wanted to kind of fix that, let's see here. We could go in And frequency. Oh, right here, you can change it to relative frequency if you wanted to look at that. So we could have it compute that. See, there's the relative frequency that we were talking about. So edit. Nope. Should be a way to change the bends. I'm not seeing it, but I'll look it up. There is a way to change the bend size. Here we go. Width. So right here, it's going to do its own thing. It's going to analyze the data and do its own thing. But generally, the bend width is 3. But let's make the bend width 1. And there it is. There we go. So because we only want the bend width to be 1, we want this to be groups of 1. This is to be the group 2. And so on and so forth. And again, we can change it back to the frequency. And there it is. See, in frequency, histograms, the bars should touch. And they were in the other one. They were just having the bends a different option. And again, you can go back in here, and if you wanted to look at full time, you can change it to full time. Keep those same settings. There's the full time information. So pretty cool. Looking at some other options that we can do here. So we talked about a histogram. You can do the stem and leaf plot. So all you got to do is just select who you want, full-time, and compute. And there's the stem and leaf plot for it. So the reason why they did this is it says the leaf represents 0.1. So that means this is 1.0. They had to add a 0 after these numbers to make it a 2-digit number to make the stem and leaf plot. Okay, so technically a stem and leaf plot looks just kind of weird for this. But you can see that there are 2 1s in here, which represent the one that was right here at 7 and the one that was down here at person number 22. So stem and leaf plot. So it definitely gives you some information right here about how to read the stem and leaf plot. Always make sure that you look at that. If you wanted to look at the part-time, just go into edit, change it to part-time, and compute. There's the part-time. You can see that it kind of changed up its options here. So it's kind of changing the width there. Let's see here. See if we can change it back. Leaf unit, that's fine. Weird. I don't know why it kind of went into that mode when it didn't do that for the other one. But you can see why, stem and leaf plots could be weird to do. Again, we have lots of data here. I wouldn't necessarily do a stem and leaf plot. But again, I'm just showing you that you can put the information in and you can have it create stuff for you. That's the big thing. Okay? And then last but not least, again, we talk about the dot plot. So again, just pick who you want. And you can change the point size. So you can have the point size be bigger. Allow points to overlap. Okay, we'll see what that does. So let's do this. Graph properties. So lots of things you can kind of play around with, but normally I don't mess with them. Okay, so there's the dot plot. All right, so my points are overlapping. That's why they're touching. So if I tell them to not overlap, I bet you they're going to be spaced out just a little bit more for us. Okay, it's the same. Just kidding. Huh, weird. Edit. Yeah, okay. But yeah, there we go. So there's our dot plot. Nice and easy. Okay, and again, you can go back in and I could change it to the part-time. Okay, some other cool things that you can do is you can print these off. You can download this. You can save this stuff, and you can bring this into Excels and Word documents. There's lots of cool things that you can do from this. You can grab this data and take and actually use it in documents. Okay, so that right there wraps up section 2.1. I don't think I have another one. Nope. So in the next one, we're going to talk about 2.2 and how we can start to analyze this information. Now that we got a picture of it, we want to analyze it. And that's going to be the big thing for the questions, because questions 7 through 31 really do pertain to 2.1 and 2.2. They kind of mix the two together. That's why I didn't tell you about any questions on this one, which questions to look at, because questions 7 through 31 are going to pertain to 2.1 and 2.2, and they kind of mesh those two up together. So there really aren't any single problems that really just deal with 2.1. It's meshed together with 2.2. So let's go ahead and jump into this next video, section 2.2, and I'll see you there.